Now, let's look at this question. We have to find the equation of a line of intersection of two what? Planes. And the first plane is that, and the second plane is that. So, you see, first of all, you have to know that we are finding the what? The equation of what? A line. And we have already established that if you want to get an equation of a line, then you need what? A vector from where? A direction, right? And what? An initial point. But with this question, we don't have the vector from the direction. And we also don't have the what? The initial point. All that we know is that there is a line of what? Intersection between what? Two planes. And let's see something. Let's see this is plane 1 and this is plane 2. When these two meet, there will be a point of intersection. And if there will be a point of intersection, then definitely we will get a vector from where? A direction. Because it's like this. One will come from this side. When these two planes meet, a normal will form here, and a normal will form here. And you know that a vector from a normal comes from what? Planes. That's why we have two planes here. So this is going to be perpendicular, and there will be a perpendicular here. And when these two meet, so the two normal vectors are going to be what? Orthogonal to what? Each other. Because you know that orthogonal is the same as what? Perpendicular. And if they be orthogonal to each other, a direction vector will what? Form. So it's going to be like this. Watch. So it's going to be like this. There is a plane 1 and there is a plane 2. So we can see that a perpendicular line can form here, and a perpendicular line 2 can also form under this second plane. So you see that when these two meet, a direction vector will what? Form. That means that the vector from a direction from P1 and P2, they are going to be orthogonal to what? Each other. And if they are orthogonal to each other, then a direction vector will what? Form. Therefore, we can say that because in order for you to get an equation of a line, you need a vector from a direction and what? A point. So for now, that means that N1 is going to be orthogonal to what? N2. That is when we will get what? A vector from where? A direction. Alright, so that means we are going to, that means that we have to bring out the vector from the normal. So the N1 of this is going to be 2, -3, 4. Then the N2. Then the N2 is going to be 1, 4, -2. Alright, so we are going to get something like this. So when you get it, okay, let's continue. So when you get it, then we find a cross product between the two. So we are going to get V to be equal to that cross that. So I, J, K. Then we have 2, -3, 4. Then we have 1, 4, and what? -2. How are you going to see that? Alright. So when you find a cross product of these, you are going to get 10I plus 8J plus 11 what? K. Alright. Make sure you do it. You get that. K. So now, this new vector that we have in here is the vector from where? A direction. So now that we have the vector from the direction, then how are we going to get the point? That is the initial point, in order for us to get the equation of the what? Of the line. So that one too is just simple. You having this, what you do is that to find a point, to find the point of intersection of two planes. This is what you are going to do. So this plane 1 and the plane 2. Here you can choose to set x to be equal to 0, or somebody too can choose y to be equal to 0, or somebody too can choose z to be equal to what? 0. Because when you choose, let's say x to be equal to 0, you are going to deal with only two what? Variables. Then you solve it what? Simultaneously. I hope it's clear. Alright, so that's how you are going to do it. So what do you think? Which one should we choose a to be equal to 0? Alright, so now this is our vector from a direction. So let's choose y to be equal to 0. You can choose any of it. So when you choose y to be equal to 0, you're going to get 2s plus 4z is equal to 3. And when you choose y to be equal to 0 here, you're going to get s minus 2z is equal to 7. Then you can solve it what? Simultaneously. And when you do that, your s is going to be, make sure you do that, okay? You can do it by elimination. You multiply everything here by 2. Then when you add, you can see that your z will go. So that you do it that way. So when you do, your s is going to be equal to 17 over 4. Then we know the y to be 0. Then we are going to get our z to also be negative 11 over what? 8. Alright, so you having this. Therefore our initial point P is going to be 17 over 4, 0, and negative 11 over 8. So that's what we are going to get. So you having the vector from the direction and the initial point. Then the equation of the line will become what? Easy. Alright, I hope from here you can continue. You can pause the video and continue with it because you have already done this. So now, to get the equation of the line, whether you want it in the parametric form or whatever form, that one, it depends on you. So, we know it's going to be s is equal to s naught plus what? 80. And y is equal to y naught plus what? bt. And z is equal to z naught. Alright? Z naught plus what? ct. So, you know the ABC here to be the what? The vector from the direction. And the not here is the what? Is the point. So s is going to be equal to alright. So that is going to be the first that is 17 over 4 plus the vector 10t. And y is going to be equal to, so that is 0, y is 0. So here is going to be equal to 8t. Then here z is going to be equal to negative 11t plus 11t. Alright, so this is the parametric form of the of the equation. So you can also choose to write it in the Cartesian form, where so the Cartesian form is going to be s y z is equal to, then you bring a point which is 17 over 4, 0, negative 11 over 8 plus t, then you bring the the vector, and the direction vector is what? 10, 8, 11. So you can do it that way.